Okay, guys, welcome to today's lesson in statics. Today we're covering problem 39 from chapter 3. So number 39 says, consider the volleyball net shown. Determine the angle formed by guide wires AB and AC. So look at the figure. We have point A, the top of the net, and it's going down the sand to point B with a stake in it, and point C with a stake in it. So what the question asks us to do, I'm going to draw it out, is go from point A and find the angle between where we have point B staked off at, and find the angle between where we have point C staked off at. So we have this angle theta in between. We have our vectors R A to B and R B to C. So we know from our dot product formula, if we were to find the dot product of vectors AB, so vector AB dotted with position vector A to C, that would be equal to the magnitude of the distance from A to B multiplied by the distance from B to C, and then times the cosine of the angle between them, as I've drawn right here. So we need to find the components of each vector, position vector, from A to B and A to C, and then we could use those to find the distance, the magnitude of the position vector for AB and BC. Now, looking at the figure, going from point A to point B, we can see in the x-axis, we're going in the negative x direction, 6.5 feet. So our position vector R, A to B, would be negative 6.5 in the I-hat direction. We're going down along this vertical axis. We're going down a distance of 8 feet, it tells us. So it would be minus 8 j-hat. And we're coming out in the z direction, coming out from the line of the pole for the volleyball net. We're coming out 2 feet in the z-axis direction. So this would be plus 2 k-hat. Now we can go ahead and find magnitude of the distance A to B, by using our square root distance formula. So we take the square root of each component squared and add it together. So we have, in parentheses, negative 6.5 squared plus 8, negative 8 squared plus 2 squared. So that tells us, we plug into our calculator real quickly. Looking at the calculator, we have, in parentheses, negative 6.5 squared plus, in parentheses, negative 8 squared plus 2 squared. Take the square root of that number. Then we take the square root of that number. Here we go. And we get distance of 10.5 feet. Good to know, very well. Now we find the magnitude and distance position vector of A to C. So again, looking at the figure, notice point A to point C is in line with the z-axis, which means our x dimension for A to C is 0. There is no displacement in the x direction. So we'd have 0 in the I-hat direction. We're going down, again, the same 8 feet in the j-hat direction. In the k-hat direction, we're coming out a distance appears to be of 6 feet. So it'll be plus 6 k-hat. We now find the distance value by doing the same formula from A to C, the same formula for each one of its components. So we have 0 squared, no, be 0, plus, in parentheses, negative 8 squared, plus, in parentheses, 6 squared. The 6 is actually in parentheses, that's fine, won't affect the answer at all. So 0 squared, no, is 0, in parentheses, negative 8 squared, plus 6 squared. We'll square root this number. Oops, actually our answer will be square root of 100. We know that square root of 100 is 10, so it'll be 10 feet. Great. So now we have our position vectors A, B, and AC. We have our distance values, magnitude of the position A, B, and A to C should be A to C. We can now solve for the cosine of theta by doing a little bit of algebra. So substituting these values in, we were to do the dot product here, we'd have negative 6.5 times 0, which is 0. I hat times I hat, which just becomes 1. We have the dot product of negative 8 and negative 8 becomes positive 64. J hat times J hat becomes 1. And then we have positive 2 times 6, so plus 12. K hat becomes 1. And then all of the I hat times other components, J hat times other components, it cancels out with these 0. So we have this value is equal to 10.5 times 10 times the cosine of the angle theta we're trying to find. So if we add these numbers up, 64 plus 12 would give us 76. 10.5 times 10, move the decimal over, gives us 105 times cosine of theta. So if we divide both sides by 105, we have 76 over 105 equals cosine of theta. So if we say, let's write this one more time, say the cosine of theta equals 76 over 105. If we do the cosine inverse of both sides of the equation, cosine inverse will cancel out, we just get theta. This tells us theta is equal to the cosine inverse of 76 over 105. So we're going to do cosine inverse, 76 divided by 105, we're in degrees. So the answer is equal to 43.63 degrees. That's our angle between the guide wires AB and AC, as shown in the diagram here. This angle right here between AB and AC is 43.6 degrees. Alright guys, thanks for joining me in another Simple STEM Solution video. Be sure to like and subscribe. Also, if you'd like to support this channel or have particular questions you want answered, be sure to check out my Patreon community via the link in the description below.